Okay, so now we're at 5.8, subtraction of polynomials. And I want to start with the definition, additive inverse. The additive inverse is any two polynomials that when they're added together, you get a 0. So for example, here's two examples. -5 plus 5 equals 0. So 5 and -5 are additive inverses. -3x plus +3x gives me 0, so they are also an additive inverse. They are opposites of each other, which remember an opposite is the same distance from 0. So now let's talk about subtraction of polynomials. And if we go back to when we talked about the addition of polynomials, we were talking about how we had to think about the parentheses before we got rid of them. And this is really important on these problems that we think about the parentheses. So what I'm going to ask you to do is I'm going to ask you to highlight your negatives just to kind of keep them in our mind as we do the problem. And we're going to keep that in our hand ready to go. So there's no number here. Remember, it's a 1, but when we distribute the 1, nothing changes. So a to the third minus 2a squared plus 4, and I'm going to keep my highlighter handy to do those negatives. Now, in this case, I want you to still remember there's a 1 there, but this is a -1, and a -1 is going to change the the sign of the numbers. So we're going to distribute that -1 to everything inside. So I'm going to -1 times a to the fourth -1 times -4a to the third. So there's a negative and there's my negative. And then -1 times -3a squared. Again, I'm going to highlight those negatives just to kind of keep them in my mind. Again, trying for that, getting rid of the parentheses. Nothing's happening up here. Nothing was multiplied or added. Here we have -1 times a to the fourth, which is -a to the fourth. If you want to write the 1, you can. A negative times a negative is a positive. 1 times 4 is 4a to the third. A negative times a negative is a positive. 1 times 3a squared is 3a squared. So now we're going to collect like terms. So we're looking for a to the third power. Well, here's an a to the third, and here's an a to the third. So a to the third, and I cross it out, plus 4a to the third. Now, I'm going to go with a to the second. Here's an a to the second, here's an a to the second. It's a minus 2a squared, and plus 3a squared. Now we have positive 4 and a -a to the fourth. They don't have any friends, anything to match them up with. Finish up our problem. So remember there's a 1 even though it doesn't seem like something's here. 1 plus 4 is 5. A to the third. Remember, candy, corn, and Smarties. These are the a to the thirds. They are the only thing I can add together, and it stays a to the third. If I had 1 candy corn and 4 candy corns, I would have 5 candy corns. It doesn't change that a to the third. Can't add it to this next part because they're candy, corn, and Smarties. This is a to the third. This is a squared. Adding these two together, I have a -2 and a positive 3. When I have a negative and a positive, I subtract. 3 minus 2 gives me a to the second. I'm not sure if I need that negative though, because 3 is bigger than a 2 and 3 is positive, so my answer there should be positive. These two don't have anything to add. Again, candy, corn, and Smarties. This is Smarties, no variable. This is candy corn, it's got variable, a to the fourth. If I go back and do my descending order, the only thing that's out of order is this a to the fourth. Remember, it's -a to the fourth plus 5a to the third plus a squared plus 4. All right, we'll do one more problem like that. So now we're looking at a slightly longer problem. Again, there's only the 1 in front of these parentheses, so I want to get rid of the parentheses and I don't have to do anything more than get rid of them. Rewrite the problem. And now those parentheses are gone. I am going to go through and highlight my negatives so I can keep an eye on them. So there's a negative, a negative, a negative, a negative, and a negative. So again, I'm noticing that this is a negative between the two polynomials. That means I am distributing that negative 1. When we did addition, we distributed the positive 1, but the positive 1 did not affect anything in the parentheses. So now I'm looking at negative 1 times x to the third y. And again, highlighting my negatives. Negative 1 times negative 2x squared y to the second. Highlighting my negatives just so I don't lose sight of them. Negative 1 times negative 2xy. And if you start to get lost, then cross it out as you do it. Negative 1 times this, cross it out. Negative 1 times this, cross it out. Negative 1 times this, cross it out. And then negative 1 times negative 3. Woo, running out of room. All right, so now let's get rid of those parentheses still. We got rid of the 1 parentheses. Now we have more little parentheses to get rid of. No parentheses up here at the front, so we're just going to rewrite those parts of the problem that have no parentheses. And again, just for right now, let's go ahead and continue to highlight our negatives. Here we have a negative times a positive, which is still a negative. 1 times x to the third y is x to the third y. A negative times a negative, and I apologize, didn't highlight that, is a positive. 1 times 2x squared y squared is 2x squared y squared. A negative times a negative is a positive. 1 times 2 is 2xy. And then a negative times a negative is a positive. 1 times 3 is 3. Let's go ahead and collect our like terms now. Up to this point, we were just getting rid of parentheses. Now we're going to look at what things are like. So here I have an x to the third y. And I go across looking for, oh, there's an x to the third y. So I'm going to put them together. And I really want to see this step, even though for some people they think it's kind of stupid. I want to see it because I'm afraid that sometimes people miss the negatives. And it's important that you know when you have a negative and not a negative. All right, now I'm looking for x squares, y squares, and here's another one. So I have a positive 2x squared, y squared, and again I have a positive 2x squared, y squared. I'm looking for an xy, and here's an xy. So this is a minus 3xy. And a positive 2xy. And when I cross those out, I'm left with a positive 6 and a positive 3. So in the case here of the x to the third y, those two are similar. They have exactly the same variable. X to the third y, x to the third y. 4 minus 1. 4 minus 1 is 3x to the third y. I keep my variable, it doesn't change. X squared, y squared, x squared, y squared. Those two are similar. So 2 plus 2 is 4x squared, y squared. So here it doesn't change. Now we're looking at xy with xy. Negative 3 and positive 2. When I have one negative, one positive, we subtract. 3 minus 2 is 1xy. And we don't have to have that 1 there. 3 is larger than 2, and 3 was negative, so that means my answer is negative. And hopefully you can do 6 plus 3 is 9. We're going to start here. Let's do one more problem. All right, again, we're going to make sure that as we go through the problem, I'm going to start by highlighting my negatives. So I'm made aware of what's there. So there's nothing here in the front, so that means it's just a 1. A 1 times anything gives you the same number back. So it changes nothing. So let's drop those first parentheses, because in our mind we're distributing that positive 1 and nothing happens. Now, here's a negative. This does affect what's in the parentheses. So, negative 1, remember there's always a 1 even though we don't see anything there, we're going to distribute. So now we have negative 1 times negative 2ab, and I want to highlight my negatives just to help them stand out. Then negative 1 times negative 3a, and again, I really want to see this step. A lot of people multiply the negative 1 times one thing and then just forget it. So writing it out helps you to see all the steps and hopefully not miss them. So negative 1 times 4. Now we're still getting rid of those parentheses. So we're looking at the fact there's no parentheses, so I'm just going to copy it down. And then I'm going to highlight my negatives just to help me be aware of them. A negative times a negative is a positive. 1 times 2 is 2. 1 times 2ab is 2ab. A negative times a negative is a positive. 1 times 3a is 3a. And a negative times a positive is a negative. 1 times 4 is 4. Now that all my parentheses are gone, now I collect my like terms. And I'm looking here at the problem, and I'm going to start left to right. So I see an ab squared, and I don't see any other a's with a b squared. So I'm just going to write it down. Now here's an a with a b. Here's an a with a b. So I'm going to put those two together. Plus a 4ab and plus a 2ab. Now here's a by itself, and here's an a. So I'm looking at negative 7a and positive 3a. And again, if it helps you, because I know it helps me, if I highlight those negatives, and then the last part is negative 4. Continuing with the collecting like terms, this is the only one, so minus 3ab squared. Again, if it helps you, I like to cross them out. Here's the two ab's. They're both positive. 4 plus 2 is 6ab. Remember, when you're adding variables, they stay the same. All you're adding are the numbers. 4 plus 2. So if we were looking at Smarties, we'd have 4 Smarties, and 2 Smarties gives us 6 Smarties. They stay that way. Now we're looking at the A's. One's positive, one's negative. We subtract. So 7 minus 3 is 4a. A 7 is bigger than a 3. So since the 7 was negative, my final answer is negative, and all I have left is a negative 4. As far as descending order goes, I'm already in descending order. Pretty much. There's A's throughout. The only thing that changed was the B, so I went ahead and did it with the B instead of the A in descending order. B squared, B, no B, but still has the A, and then no A or no B.